Although we fully implemented the SignInFormBloc in the previous part, we still cannot actually sign in using Firebase. Until now, we have successfully hidden Firebase Auth details behind a nice interface called IAuthFacade through the power of abstraction. Now it's time to provide a concrete implementation for it while using GoogleSignIn and Firebase Auth. Hello, welcome to ResoCoder, where you are getting prepared for real app development so that you will get freelance clients or a job and be confident about the apps you build. So subscribe and hit the bell to join us on our quest for becoming in-demand Flutter developers. Before we go any further, I just want to let you know that these kinds of tutorial series on this channel are no longer going to be supported with written tutorials. There is still going to be code published as always on GitHub, so you can go there and really study the code at your own pace, but there will be no written articles. So the first thing we should do here is to create a Firebase project, because actually up until now we did not have any Firebase configuration inside our app. So we're going to open up a browser and go to console.firebase.google.com, log in with your Google account, and we're going to hit here Add Project. We're going to call this Note App and then just click Continue. Then we're going to just enable Google Analytics. We don't really care about that. Continue. Google Analytics account will be default account for Firebase. And now let's hit Create Project. After some time, the project is ready and we can go ahead and continue. And now we just want to set up our Android client. Of course, you can also set up the iOS client, and that's actually a bit simpler to set up, but just for the purposes of this tutorial, we're going to focus on Android to keep this short and simple. So let's click on this Android icon, and I actually don't know what is the package name of the app. So let's go ahead and go to VS Code, open up the Android folder. We're going to hop into app, build a Gradle, and here we can find that it's called what? Oh, here it is. Com ResoCoder blah blah blah. So we're going to copy this, and please copy your own package code because otherwise it's not going to work. We're gonna paste it here. And now we need to provide a debug sign-in certificate because we are gonna be using the app in debug mode, and we will want to sign in with Google. And sign in with Google requires Google to know the sign-in certificate, not sign in as in sign in, but signing, right? And since we are in debug mode, the app is signed with a debug key. And pardon me, I just made the font a bit bigger, but you didn't miss anything. We just filled in this Android package name. So we want to go to this page. And here it writes how we can obtain the sign-in certificate. I'm on Windows, so I'm gonna just copy this command and hop into VS Code. Open up the terminal. I'm using PowerShell. Paste this in here, and it sort of didn't work. That's unfortunate because, as you can see, this command is provided as two parts with this slash, which signifies new line. I'm not sure why they provide it as this. At least on Windows, what you need to do is to paste it, for example, to the address bar in the browser, remove the hash or remove the backward slash, excuse me. And now we're going to copy the command without the backslash. And now we should be able to use it just fine in the terminal. Once we do that, we see that we have an error popping up on us, which is unfortunate. So maybe you just cannot use PowerShell. Maybe we can use a regular command line. Yeah, these things are very funny sometimes. So now we're gonna use the regular command line. Let's try that. And as you can see, we can use regular command line. So Windows users, you probably cannot use PowerShell with this command. Anyway, we're now gonna enter the key store password. And since this is a debug key store, the password is just Android. And here we go. We have the SHA-1 fingerprint here. We can just copy it. And once we have that, by the way, this is completely fine if you see this because it's just a debug key store anyway. Now back inside the browser, we're gonna paste this SHA-1 debug sign-in certificate into this field and register the app. Once that will be done, we'll be able to download the config file. Awesome, so we can download googleservices.json and we're going to put it into the project folder, which we have opened in VS Code. Go to Android, app, and save it there. So when we go to VS Code, we can see that we have the Google Services JSON file right here. Now, what's quite important to do is to add this file to gitignore for Android. So just go here and we're going to say Google Services.json. Save this gitignore, which is present inside Android, and this way this will not get added to the Git repository, which is pretty important because you now want to keep your sensitive details inside a Git repository, especially if you have some sort of an open source project such as this one, because I'm publishing it on GitHub for everybody to see. All right, with this gitignore and also the Google Services JSON file here, we are now gonna be able to use Firebase. But in addition to all this, we also need to add some native dependencies to the build.gradle files for Android. If you are on iOS, you actually don't need to mess with any native things at all. It's all gonna get done for you. But on Android, what we need to do is continue in the setup. So hit next. And now we wanna add Firebase SDK. So we want to copy this line. We're going to hop into the project level build.gradle. So not the one we have currently opened under app, but only the one which is in the Android folder itself. We want to go to build.gradle there and now go to dependencies, I guess, and paste this line here. So we are depending on Google Services. And now let's scroll down in the console. And we also need to apply the plugin Google Services in the app build.gradle file. So let's scroll up and we're going to apply the plugin right here. And then also we need to add Firebase Analytics. If you are using Analytics, we are actually not going to be using them. But anyway, let's just add it over there to dependencies. Just add it like this. And now with all of this set up, we can now hit next. We are not gonna verify installation. We don't care about that. And now we are inside our app in Firebase console. So now what we need to do is just to go to the authentication tab, go to sign in method, and we wanna make sure that we have enabled email and password sign in. So let's just hit enable. And then also Google will be enabled. Okay, project support email and save. With all of this done, we are now gonna be able to use Firebase and also Firebase authentication from our Flutter app. Although it's gonna take some time until we get to the point of having a user interface to use it all, but at least we know that we have everything set up, so we don't need to care about this anymore. Now what we also need to do is to add the packages which are Flutter specific, because we have set up the native Android part, but also there are regular pub packages. While we are at that, let's also update some of the already out of date packages which we have added previously. For example, Freezed now has a newer version, so let's update that. And yeah, that's about it for now. The packages which we want to add are Firebase Core, Firebase Auth, and also GoogleSignIn. So let's just add them here. And as always, you can get the code not from the written tutorial for tutorial series, but from the GitHub repository. And because we have updated the freeze package also, let's just make sure that everything is still working properly by running the build command. So we're just gonna say flutter pub run build runner watch and with delete conflicting outputs just to be safe that the new version works. And by the way, always make sure to check on the GitHub repository for new versions if you are watching this in the future, because there are probably gonna be some breaking changes down the line, and I'm gonna make sure to go through the project on GitHub and update the existing code periodically. All right, so some of the code was regenerated, but we don't have any errors, and that's cool. We can now close out this code generation. And let's focus on the facade. First of all, we only have the IAuthFacade, which is the abstract class, or in other words, interface, but we don't have any class nor a file which should hold the implementation. And where should the implementation of an IAuthFacade be held? Well, it's a part of the infrastructure layer of the auth feature. So under infrastructure, we are going to create auth folder, and inside of it, we are going to create Firebase Auth Facade. It's inside infrastructure because we are going to be dealing with third-party dependencies. And the reason why the interface IAuthFacade is in the domain layer is because the interface is completely independent of any third-party dependencies. It just defines a contract, and that contract should be fulfilled no matter if we use Firebase or some custom authentication solution. This facade's contract needs to be fulfilled. That's why it's in domain. But as soon as we start dealing with the specificities of Firebase, we need to move over to the infrastructure layer. All right, so let's create a class, Firebase Auth Facade. It's going to implement IAuthFacade, and we are going to actually deal with dependency injection later in a specific part just for that, where we are gonna set up injectable and get it and all of that stuff. But for now, let's just populate this class with a few fields. Final, Firebase Auth is a dependency for Firebase Auth Facade. Obviously, we need to have Firebase Auth if we want to sign in with Firebase. So Firebase Auth is the dependency field name, and then also final, GoogleSignIn. GoogleSignIn is its name. Now let's create constructor for final fields by hitting Control and dot, and let's also import the library for Firebase Auth and also GoogleSignIn. And lastly, we are going to create 3 missing overrides, and those missing overrides are of course register with email and password, sign in with email and password, and sign in with Google. And for some reason password changed into PARD, which is interesting. Anyway, now we have fixed the issue. We're good to go. Let's just format this code a bit by providing commas where they should be located. Additionally, let's also make these parameters required, and let's import required from foundation. And I know you can also import just meta, but I don't care. I just wanna import something quickly. So let's jump into register with email and password first, right? What we should do here is to call Firebase Auth dot create user with email and password. The problem though is that the method on Firebase Auth does not have the concept of our value object, email address and password. It expects a string. And indeed, email address is just a string, which is validated, and the same goes for password, which is a value object holding a string. So what we need to do first before calling this create user with email and password is to extract the value held inside that value object And we can do that by doing something like final email address string. And we are going to say email address dot value dot get or else. And if it's not a valid string, so this value holds a value failure, we can say failure. Oh no. And this way, this email address string will either hold the proper email address, or if the email address entered is invalid, this email address string will hold the failure in all caps. The problem is this kind of behavior does not make sense. Because think about it. In the previous part, we have implemented the SignInFormBloc, and we are just not going to be able to proceed from it if there is some sort of a failure happening in the email address or password. For example, if the email address is invalid, we are physically not going to be able to press the sign in button. So this means that if we get to the Firebase Auth facade, register with email and password method, and the passed in email address is invalid, something is wrong in our app and we should fix it immediately, because this state should not ever be possible. We should simply not be able to get to register with email and password if the entered email or password is invalid. And what do you do when you get into a state which is completely invalid and doesn't make sense? Well, you throw an error. Not an exception, but rather an error. Errors in Dart, at least as the convention goes, are reserved for things which should just crash the app because we have arrived in an unrecoverable state. So let's create such an error, shall we? We are going to create it inside domain and core, because errors are really not specific to any sort of a layer, they are just some core thing. So we're gonna create new file, errors.dart. These are not failures, these are simply things which are thrown as usual, and they should specifically be used to crash the app. We want the app to crash if we arrive in an unrecoverable point. So we're gonna create a class unexpected value error. It will extend error. And inside of there, we are going to store a value failure. And value failure, of course, comes from failures.dart. It's the freezed union. So we want to store the value failure which caused this unexpected error. So we're going to populate it in a constructor. And then the thing which will be printed out to the screen or to the log or to the debug console is going to be, of course we need to override to string, is that we have encountered a value failure at an unrecoverable point. And I'm gonna spare you of me writing that out. I'm just gonna paste it here, and you can get this string and all of the code from the project on GitHub. Link is in the description. But actually it would be quite nice to see also what the error was. So we're going to say also failure was, and say value failure here, which is gonna be automatically converted to string. But this string is quite long. So what we're gonna do is extract this part to its own constant string, explanation, like that. Now we're going to interpolate the explanation. Also the terminating should be part of the explanation. All right. And now this is good enough, but errors should not have any weird characters inside of them. And that's why it's best to use error.saveToString method and pass in this string. This is gonna ensure that any sort of an environment, some command line, which is like from the 80s, is still gonna be able to display the error. I guess that's what this save to string is for. Once we have this done, we can hop into Firebase Auth Facade. And what should we do? Well, instead of get or else and returning failure if the value is left value failure, we are instead going to throw an exception when an unexpected thing happens. The way we can do that is by saying fold, and if the value is on the left side, we are going to throw unexpected value error and pass in the failure. Let's actually rename L to F to make it clear that we are dealing with the failure. And then if the value is correct, we are going to just return R. But of course, we don't want to do this everywhere we have some sort of an invalid, unrecoverable state. So that's why we are going to move this monstrosity into the value object superclass itself. So let's just copy all of this, or cut it out actually. We're going to go to email address, value object, superclass. And once we are inside the value object superclass, we are going to create a helper method on there, which will be get or crash, and it will return t. And t is of course the value or the type of the value which is held inside the value object. And we're just going to say return value fault unexpected value error. Let's just import everything here and we are good to go. And also, so that you will not go away without gaining any functional programming knowledge goodness, this R, arrow R, is fairly self-explanatory. We are simply returning the value of the right side of either this one unchanged. This is good enough, and I think we can remain at that. But just so that you learn something new, this is called identity, because after all, we are returning an identical thing. We are not changing anything. We are not returning anything else. And there is a function which we can call from darts, and it's called ID. If we go there, you can see that it receives something and it returns that something unchanged. So that's it. You can also use this identity function. I'm also going to comment this in, just so you know, when you check out the source code on GitHub. And also, it's not bad to document what this get or crash method does, because it may not be self-explanatory. So that's why we are going to provide a documentation. So 3 slashes, and now we're gonna say throws unexpected value error containing the value failure. So now what we can do is hop into Firebase Auth Facade and just call email address get or crash. If we check out what get or crash does, we can see that it throws unexpected value error, blah, blah, blah. So now once we get to register with email and password, and for some reason, which is completely unknown, there is an invalid thing held inside the email address, we're going to crash the app. And that's precisely what we should do. Because again, this situation should not even happen in the first place. It's completely in our power to prevent it by writing good code. The same thing which we have done for the email address is also going to happen for the password. So password string. And with that done, we have the email address string and password string, and we can now pass them over to the create user with email and password function. So email address string goes in there, password string goes also there. This returns a future containing auth result, which we should probably await, right? So let's create, or let's make this function async. And I am sure you remember from the previous parts that the infrastructure layer, which is also this Firebase Auth facade, is responsible for converting exceptions into failures, which are then held inside either. So we should handle any exceptions which this create user with email and password function can throw and convert them to our nice auth failures, which we have created a few parts back. So for example, we have failure email already in use, or invalid email and password combination, and so on. If we take a look at the documentation for the create user with email and password method, we can see that it can throw 3 types of errors: weak password, invalid email, and email already in use. If we take a close look at this, weak password and invalid email are really not something we need to worry about here, because we are already preventing these invalid emails and weak passwords from even entering into this function in the first place, because we have good validation in place inside our value objects, email address and password. And of course, even if you are not going to the extremes, and by the way, I don't think I would go to these kinds of extremes with value objects like ever, because yeah, it really takes so much time to build this up. You mostly don't need this, but we are just demonstrating the domain-driven design principles here. We are going by the book and abiding all the rules, but I don't think that you really need these kinds of objects in a mobile app. But anyway, even if you do not have them, you are still going to validate the form, and you are still probably not gonna get to this method with invalid values for the strings of email address and password. But what does interest us is this email already in use error. So we would definitely want to catch that. So try catch. Let's move this up top. Catch will be also here, but of course we do not just want to catch anything. We just want to catch platform exceptions, because that's what is actually thrown from these Firebase methods. So on platform exception, catch E. And now how can we differentiate between these sorts of errors? Because we are really interested only in email already in use error. And the way we can differentiate between these different types of errors is to check if e.code is equal to, and now copy the email or the error code which we are interested in. If the code of the platform exception is this, we are going to return left and const auth failure, not canceled by user, but instead email already in use. And then also we're going to otherwise return left const auth failure server error. Why? Because if the error returned is either weak password or invalid email, it should not have happened really, but in case it happens, we are just going to show a generic server error happened message to the user. The problem is that if you take a look at these squiggly lines, they say that this function has a return type of this, but doesn't end with a return statement. Why is that? We are returning left from the catch statement, but we are not returning anything from the try block. So if there is no exception happening, we are not going to return anything, and we need to return something. So what can we do? Well, we can return right unit, because unit is used inside either to signify that nothing wrong happened. It's sort of an void for either, which I have already explained in the previous parts. Now that we already have all of this done, it's gonna be extremely simple to also implement the sign in with email and password. Actually, let's just copy the content of this register method, paste it inside sign in with email and password method, make it async. And the changes here are pretty substantial so that we really cannot refactor this code later on. We need to have these separate methods almost copy each other. That's just how it needs to be. Because we need to call sign in with email and password and also handle different errors, because sign in with email and password can throw invalid email, wrong password, user not found, blah, blah, blah. Too many requests. We are not going to care about every of these errors. Instead, we are just going to care about error, wrong password, and error, user not found. Because if you think about it, error, wrong password means that the password is wrong, of course, and error, user not found means that there is not a proper email address, or actually that the email address which is entered does not belong to any user. And in either case, so error, wrong password and error, user not found, so or e.code is equal to error, user not found, we want to return the very same auth failure, and its name is invalid email and password combination. Why is that? Why do we not have separate failure for wrong password and a separate one for user not found? Why do we join them together? Well, the reason for that is that if we set wrong password to the user in the UI, that user, if he tried to be malicious, could know now that the email address is actually correct and only the password is wrong. And what could happen then is that the user could do a brute force attack or just simply try to hack the account, because that user, which is malicious, would know that, oh, that email address is already present on the backend, I just need to find out about the password. But with this sort of an error message, invalid email and password combination, that potentially malicious user cannot have any clue if it's actually the email that's wrong or if it's the password that's wrong, right? So we are making it a bit harder for the possible malicious person to hack into the data of an unsuspecting user. And again, otherwise, so the fallback case for all of the other errors, we are just going to return a generic server error, because yeah, that's about it, what the user needs to see. And of course, you can always log this error to your error handling reporting system like Crashlytics, so log, and you would be able to log the error here and so on. Of course, we're not going to do that. That's outside the scope of this tutorial series. Lastly, let's implement sign in with Google, right? This is going to be a bit different because we do not get anything passed into the sign in with Google method. We actually need to call something on the Google sign in instance to initiate the pop-up where the user actually provides their information for the Google account. So what should we do? Well, we should call Google sign in dot sign in, of course. If we check out the documentation, we can see that it returns a future. So that automatically tells us something that we should make this method asynchronous. Return future resolves to an instance of Google sign in account for successful sign in, or null in case sign in process was aborted. And what do we have as an auth failure? We have canceled by user. So what that tells us is that if the return value by this method is null, so final Google user is equal to that, and if Google user is null, we want to return a failure, so left auth failure dot canceled by user. All right, cool. I'm not sure why it doesn't want to return anything. Interesting stuff. Of course, because it's not async. Silly me. Anyway, now we need to await the sign in call. And we're done here. Not quite, but at least for this part of the code. But what should we actually do with the Google Sign-in account, which I have called Google User? Well, this Google Sign-in account can provide us with authentication object, which holds, or actually this is a future, but this value holds an access token and an ID token. An ID token is an OpenID Connect compliant token, which is used if you want to authenticate with Google. It's a JSON web token, but we actually do not need to care about its implementation because we are gonna let Firebase handle everything for us. We just need to pass it over to Firebase and it's gonna be all done and set. So what we want to do here is to actually grab the authentication from the Google user and store it inside a separate variable, final Google authentication is equal to this, and of course we need to await it because it's a future. This is just a Google specific authentication, but we are now dealing with Google services themselves. We actually want to use this inside Firebase. And Firebase does not understand the Google Sign-in authentication object. Firebase understands only something called a credential. And every major sign-in provider for Firebase does have an auth provider implemented. Let me show you. For example, there is the Twitter auth provider. This comes from Firebase Auth. There is also GitHub auth provider. This also comes from Firebase Auth. And similarly, there is the Google auth provider. And what we want to do here is to get credential, and we are just going to pass in the Google authentication .id token and then also Google authentication access token. Format everything so that we can see it on the screen, and this will return an auth credential. Auth credential is nothing complex, it's just a simple object. Let's just actually see what it is. Auth credential is a simple object which just wraps the ID token and access token. It's that simple, it's nothing fancy. It's just a simple wrapper class. And by the way, you may be thinking that, okay, cool, but for signing in with email and password, we did not need to obtain any credentials, right? We just passed those email addresses and passwords right into some method on Firebase Auth. We did not need to get credential or nothing. Well, of course, that's true, but what's happening behind the scenes is that Firebase calls email auth provider, get credential, and passes in the email and password to that method to obtain auth credential. It's just hidden from your site because Firebase doesn't want to add any unnecessary boilerplate to your code. But even in the case of email and password, you should know that you are still actually dealing with credentials, only they are hidden. We're gonna store this credential inside final auth credential. And with this, we can now use it to sign in with credential on Firebase Auth. Sign in with credential and pass in the auth credential. With this all set and done, for some reason we have an error. Oh, of course, we are not returning anything, that's why. That's because we should return either auth failure and unit and not an auth result. Since I have already written the return keyword before calling this method, what we can do instead of just splitting it up and awaiting the call and then simply returning right unit, what we can do instead is to use the other syntax for handling futures in Dart, which is the chaining with then. And when we obtain value, which is the auth result, right? So R for result. We are going to return unit, right unit. All right. And we actually don't need to use the await keyword anywhere because we are just returning the future itself. We are not awaiting anything. And of course, even sign in with credential can return an error, but we are actually not interested in showing the user any kind of these errors because they are really not something that the user should worry about. Again, we can log them to Crashlytics and do all sorts of stuff with them, but the user should not be aware of these sorts of low-level errors. And for that reason, we are just going to ignore them. So let's just wrap actually this whole function body inside try catch. Copy this code, or let's just move it up. Try on platform exception catch, and we don't actually need to worry about what we caught, so we'll just provide an underscore there, and we're going to always return left server failure. Whoa. So auth failure, server error, like that. And let's also make this constant, which tells me that I did not enable proper linting because we should be getting the messages that we should use const whenever possible. So in the next part, we are going to enable dependency injection and do all sorts of things for maintenance, like for example, the just now mentioned linting. So in this part, you learned how to use Firebase and also GoogleSignIn to provide an implementation for our Firebase Auth facade. You have also learned how to handle unrecoverable and actually quite nonsensical states, because something like an invalid email address this deep into our layer structure should never happen. That's because we should catch something like an invalid email address right in the presentation layer, or actually in the application layer, if you know what I mean, inside this SignInFormBloc. This is where we should stop anything from happening if there is some sort of an invalid value inputted. But in case something like that happens, we are going to crash the app because that's the proper thing to do. In the next part, we are going to do some sort of a light maintenance work, like setting up injectable for dependency injection and also enabling linting and just making sure that our code will remain healthy and maintainable throughout its lifetime. I hope that this more of a off-the-cuff recording of this video is something that you enjoy, because I don't have anything scripted, I don't have any article to follow, but as always you can get the code from the link in the description, which in this case is not gonna take you to resocoder.com unfortunately, but it's going to take you to GitHub. And if you are serious about becoming a great Flutter developer who can build real apps for clients or at the job, go to flutter.education, link is also in the video description, to get the top curated Flutter news and resources aimed at improving your app development career. Over there you can also subscribe to my mailing list to get the best Flutter resources delivered weekly right into your inbox. And if you don't want to miss more tutorials like this, be sure to subscribe to this channel and also join the notification squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder, I am determined to provide you with the best tutorials and resources so that you will become an in-demand Flutter developer. If this video helped you, again, give it a like and also share it with our developers who are surely going to find it beneficial too. Leave a comment and see you in the next video.